hoping you can enlighten him about it.
Would you, the field medic, like to tell what you have here, or?
Tell what I got?
Yeah.
Sure. Well, this is our field tent for our medical station. We've got a shower, emergency wash down. Plenty of supplies. Don't know exactly what we've got yet. We'll have a first aid, kind of a minor first aid area right at the table. Anything major we would take inside. Any heat exhaustion and whatnot, we want to get them into the shade. Would work good. Jack mentioned you put an ice machine in there from the generator trailer. That would be pretty cool.
Okay. And as far as the positioning and shading of the area, we have it camouflaged from the road so that you can't see exactly where the tent's at. Only the people that need to know where it's at. Best camouflage as possible. And you got shade almost the whole day except for, about 2 to 4. So,
yeah.
Best place for a medical tent.
Yeah, we've got plenty of space. We got to drag people through here and for the training, something like that.
Hopefully nothing serious yet.
Yeah. Something only trips hits her head or something.
Oh yeah, that'd be bad.
Yeah.
I don't think we can quite do trauma yet.
Yeah. Anything can happen, you know. By sneak.
The idea is to position the tarp so it's just under the edge of the tent.
Okay.
Don't do that yet.
All right.
Because the sticks have to go into the ground. The tarp's in the way. So, I'll hold the tarp up underneath.
All right.
And hold this up for me. Without pulling the pins out, hopefully. Yeah, hopefully. Okay. Okay, you ready, my friend?
I'm coming around the tree.
Taking a scenic route?
It's called Wish.
Antler.
I think this is. It ain't very big. It's probably window. I think that's probably the front right there.
Yep. Does that go over the far side?
No.
Or does that go over the door?
I think I'm standing at a
This
window.
is the marker for one of the doors. So
Yeah.
let's turn it around so this is facing away from the road. You go down there, watch the tree limbs.
Yeah.
Bring it up over the top and not into the tree limbs. Watch your feet, feet, feet.
No, I think it's straight out.
That'll work.
Handle? I got a corner here. There we go. Want to start sitting it down?
As long as we're sure we got it in the right spot. Okay. All we need now is a radio and we're ready to go. Mark brought up a good point earlier. Everybody get up, get around the demonstration so I can get you all in the shot.
Make it look like we're learning.
Yeah, try not to look quite as stupid as usual.
Can't help it.
Oh man, that is a good shot.
Okay, we have the radio that goes on to here, of course, plugs into here. Mark pointed out a good point. In the event of strong winds, we can do one other thing here. Add another piece onto the bottom, expanding out the base on here. This, of course, will go up a little bit from here, which will give you more room to trade out the mast sections going up. But it'll give you the more height and more stability. And as I mentioned earlier, there's also a ring that fits right in between these sections here. It's a guy ring that goes onto it that goes out in 3 different directions from there. From there we use some lanyard. Most of the time it will be camouflage so you can't see it. It'll be easy to trip over, but nonetheless it'll be there. I also recommend the fiberglass stick up at the top rather than the metal one that we have up there now, but this is strictly for training purposes, and it'll give you a good idea of what we're really talking about as far as usage goes. Now, there's one other thing you can do. You can bring this up a little bit and put a wood block underneath here, mainly for rain purposes. Put a hole, recess down in the wood block and a hole out of the bottom of that to drain out the rainwater that may happen to accumulate inside this tubing.
I missed the part about wrapping the wire. What was that about?
It wasn't.
Add in.
No. Wrapping the antenna tube.
That was Alex.
That was Alex while nobody was looking.
Yeah.
Is that just to avoid having to zip tie it?
Yeah, that's all. And the other thing is that you can use camouflage duct tape, okay? And duct tape cable right to the mast section going up. And you can extend on. This connector right here with a barrel connector, you could basically go up 100 feet if you wanted to, if you had enough sections here. Each one, of course, is 4 feet, but you can go up to, whatever level it is that you want to. You can add on additional coax, which will fasten right into here. Okay? One other thing, in the event that you have a question relative to the where this is going, as far as height and so on goes, and once you start putting the down guys on it, you just sit out here with this, put a weight on the bottom, hold this string up, and if this string runs parallel with that mast section, you're straight up and down. Newton's law prevails on a deal like this. Okay? And that's the way you check it. All you really need to do is to check it from 2 different directions.
Okay. Bob.
Yeah.
Would you like to explain what the significance is of straight up and down?
Vertical.
Well, in terms of antenna theory.
Right. The vertical part is the fact that you're going to have a radiated pattern off of the transmitting antenna in the full 360 degrees. If you have it slewed off to one side, then your radiated pattern is going to be more off to one side than the other. In other words, you're going to end up with more of a sky wave than you will a ground wave. And the secret here is you want as much ground wave as you can possibly accumulate. Okay? So that's the idea behind having this as vertical, straight up and down as possible.
Jeremy, stop there. Face the instructor.
Okay, questions? What? This was all clear as could be?
I already asked a question.
When you're plugging in, maybe you'll get to it. When you're plugging in,
Yeah.
you have to be powered down.
Well, not necessarily. You know, the radio can be in a receive mode, but it's always best to have the antenna connected to it before you turn on the radio. And the reason for that is, in the event that happen to hit the microphone button before getting the coax on it, if you do it for a prolonged period of time, you'll burn the finals out of the radio. And they're transistors. Unless you really go back a number of years where we have the tube type. But you guys probably won't be operating with tube with any kind of luck. Everything you'll have will be transistorized radio. Okay.
Okay.
What else? Other questions?
Is there a limit on the output of the radio for the antenna being used?
It would depend upon the antenna. Yeah, some of the antennas are only rated at 50 watts. Some of them are rated at 100 watts. Some of them are rated at 500 watts. And there's another antenna that we won't even get into yet that is rated at 2,000 watts. Okay, and it would require two of these up approximately 30 feet in the air to provide you with the long wire antenna or the dipole that we use. Now, we could also put the other antenna that we have on here up there underneath the ground plane and use it as a beam. Now, in order to do that, we put a rotor underneath that, and it rotates the entire antenna around full 360 degrees. If we rotate the ground plane antenna sitting at the top up there, what's it going to do?
Exactly what it does every other time.
Absolutely. There won't be any change whatsoever. Okay? It'll still function just exactly like it does. The idea behind having a ground plane antenna is the fact that it transmits the full 360 degrees and it receives the full 360 degrees. The problem is that you don't have the directionality off of the ground plane. Therefore, occasionally you may want to have what's known as a coax switch. You can switch between the ground plane and the beam. Now you've got something going because there's a ground plane and a beam coupled up there at the top. Okay? You can pick up the signal to begin with, and then you can switch over to the beam antenna and you can actually locate the approximate azimuth from where that is operating from. Okay? By looking at your S meter, you can tell real close if it's a continual transmitted signal where it's coming from.
That'd be good for finding some lost soldiers or something if they're calling from a
You bet.
personal radio.
Yep.
Did you mention already a distance as is right now, how it's set up?
For transmit and receive?
Yeah, what would be like an average distance that we're looking at with this setup right now?
Well, we'll find out. We'll kind of
Okay.
give you an idea how well it doesn't operate in a
It's
short
all
period
about-
of time.
Okay.
Jack's going to bring his other radio out here. It's on charge. It's a battery operated radio, and we'll see where it's coming from. In the meantime, while we're waiting on that, I want to give you an idea. Okay, here's something to think about. This is your lost soldier's call sign. This is his transmitted signal.
So if you were lost, you would be playing there when you walked around.
You could. Here's his call sign. K0CKE. Okay? Right there. Now, we don't know where in the heck he's transmitting from, do we? We don't have a clue.
Or the thing spins, you'll pick it up and then lose it. Pick it up.
You bet. And there's an S meter right here on the bottom, and the S meter stands for signal meter. Shows the signal strength of the station that you're looking for. As it grows stronger, you're pointed more directionally to it. as it grows weaker, you're getting away from it. That signal that you heard, gentlemen, we're going to find that. We're going to find that guy. He's stuck, he's buried, he's injured, he's somewhere. But we're going to find him today.
Approximate distance with this? Only bearing.
Just bearing. If you're really, really, really good, you might be able to. But the problem is that you don't know what the strength is on his battery, what the equivalency factor is on his antenna, how efficient or lack of efficient that antenna happens to be. So, you know, if you know what his actual output power is, and this has a tendency, this can do 1 watt, 2.5 watts, and 5 watts. So we really don't know what power setting it is that he may be transmitting.
So you can't see the strength that's indicated for range.
Range would be, you know, pretty much out of the picture as far as any of our way equipment that we have.
That would go for any type of RDF type of.
It would.
You wouldn't be able to know your distance at all.
The guy could be
Just
20 miles away with a kilowatt.
Yeah, as long as you know you're in that direction, then you got to start your search from here in the south.
Right. My apologies if you already covered this. You mentioned a rotor earlier.
Yes, I did.
Could this young man be our rotor?
Possibility would, you know, you probably wouldn't want to sacrifice him for that. Okay? He could do that, and he could rotate it, but
That's one less
if you've got an electronic rotor up there and a rotor control box, you know, in your combo van, then that's the way to go.
All right, we'll need your recommendation for directional antennas and for rotor.
So the directional antenna is right behind you.
I need it in writing, Bob. I would distribute to everybody else.
Am I wrong, or wasn't before it became automated? There would be like a screen that you could tune it, or people literally right here on the pole.
Right there on the pole. Yep.
Do your direction finding now, Bob.
Well,
fast as the rotor.
it's relatively slow. Okay. It'll cover a full 360 degrees in about a minute. So it's 180 degrees in 30 seconds.
These kids are too young to remember back when we had those rotor controls for our TV antennas out in the country.
Said it again.
Yeah, we had a rotor control like that on top of my TV when I lived in Iowa.
Yeah. So yeah, that's what I was thinking of the manual. I think something will have with that manual too.
Those in our RV.
You could do that.
Yeah. See them.
Okay. Well,
Are we ready?
we're ready to put your radio on the air.
All right, gentlemen. Hydrate.
Okay. While you're recouping that or whatever, we'll go with more questions.
Will that function if, let's say, the antennas were bent? Let's say someone dropped it or whatnot. Let's say one of them happened to be tweaked upward. Would it still function?
They will. What happens is you change the match just a little bit, and you're probably not going to increase the efficiency of radiation by bending it. In other words, if they're all equal all the way around, your match, which would be the match between the antenna and the radio, would have its greatest efficiency. And in order to do that, there's a couple of ways to do it. You can check the standing wave ratio with an SWR meter, or you can use an antenna analyzer, plug it in, and determine what kind of a match it is that you really get. And it will show you, it'll read out to you the actual frequency that you're looking for, or the fact that you've got the best match at that particular frequency. Now, one other thing I want to point out, and that is, you notice that on the antenna, we've got the fiberglass unit at the very top up there. The fiberglass unit is going to provide us with the minimum amount of capacitive interference by using the fiberglass one. If we put an aluminum one up there, which is what we've got a bunch of, okay, our capacitance is going to change a little bit. And so, therefore, we may not have the actual effective radiated power going out of the antenna as what we would have, and it may cause a slight mismatch by using an aluminum one. So go ahead.
Would it be good to do 2 fiberglass then start going with aluminum?
In this particular case, all you need is one, because it's attached right to a fiberglass unit.
So it's like an insulator from the aluminum, right?
Yes. Yep. Absolutely.
Gentlemen. Well done, Bob.
We're only halfway there. Okay.
We
Thank
still
you.
have to run the test.
Yeah.
They're expecting our test between 2 and 2:30, right?
Yeah.
What
But
time we got
Aisha's
now?
standing by the radio too, so we can.
Can I borrow your table?
Yeah. Can you use that?
Are there handheld units that can plug into that?
Oh yeah. This one that I have right here.
Oh, okay.
We can fasten that right into it.
With the right adapters, you can hook up anything to anything.
Okay.
Well, I wasn't sure if there was, say, like a power requirement to push enough juice, or.
Well, that was what I was intending by my question, Bob. For a particular rating of antenna, do we have to push that much power, or can we use a smaller amount of power with the same big antenna?
Okay, well, and that's a good question. I like that.
Let me explain that.
Are you taking that plane downwind notch?
Come on over here to this clear spot, guys, for just a second. We're going to go over here to Ant City. Let's say we've got an antenna that's sitting right here. And we're radiating with a handheld. If we're 1 watt, our distance out would be out like this. Okay? If we're 5 watt, and I can't tell you just exactly what that would be, because this distance between where the antenna is and the outside limit out here would be dependent upon the terrain, the gain of the antenna, the loss in the coax, and the gain of the antenna of the individual that we're trying to talk to. Okay? So this is a variable factor. All of our factors are variable factors. Now if we're going to transmit with 5 watts, okay, we would be out in this area out here. Now this may be 5 miles here, 10 miles here. Can you see what's happening? The more power you stick into it, the more efficiency you have relative to coax. Now we can use a thinner coax on that. We can use RG58, which is just, a little 1/4 inch coax like you use on the TV. Okay? And that isn't nearly as efficient as that RG8. So we have our set. Okay. Now, if we're going to transmit with 60 watts, we could be way out here. Alright? Again, the height of this antenna is sitting right there. The loss of the line and the transmitted power are all going to tell us how far we're going to get. So how do you determine what we're doing here, where we're going to be? Alright? We do a field strength test. We send somebody out from the location where we've got our transmitted site with a radio on appropriate frequency, with what we would normally contact an individual with, probably an HT. And we would see how far out it is if they're able to be out this way, out that way, over to here, and down to here. Now if there's a mountain line that's blocking off in here, unless he flew up to, got up on top of that mountain, which would increase what? The height of where he is, right? Which would increase the range that he needs to talk back to the original site. But if he gets on the other side of it, chances are with VHF, he's pretty much out of it, because this mountain range that goes across here is going to block out his signal. It's a ground wave type of a thing. Okay? In other words, when we transmit right alongside the ground. VHF will cover the majority of brush and, other different things. But when you get into rocks, crevices, ravines, canyons, over the mountain, get the rock unless we pick it right. Absolutely. That's exactly what it is.
You're talking about VHF.
No, not necessarily. Well, I would pick the one that we're going to be using. What we need to have as far as communication, and we can switch between VHF and UHF with that antenna or with the other HT, this one here. It's covered both. VHF and UHF. It's covered with a 1 meter band, 7 centimeters. Either way. But your major transmit capabilities, your major range will be on VHF. The only time you may want to switch over to UHF, find out if somebody out there creating problems. Every once in a while, you'll find somebody with jam your radio service. They can be out there just like this, and you won't be able to probably talk over it. No, they're going to jam whatever they happen to find you on. And that's the time when you need to switch over and have that capability. Yeah, but chances are they aren't going to have a direction. Chances are they're just going to obliterate the channel, the frequency with as much RF as they can on your particular frequency that you're trying to.
Let's say that somebody picks up the radio, they don't know
RF output?
how much output is very average
If you're familiar with your radio equipment, you'll know. You're going to know that it's either 1.5, 2.5, or 5 watts. And some of them are 6. Very few of them.
I was just thinking.
If he's brand new, he probably doesn't have the capability to run one of these radios because he's not an amateur radio operator. And if he is an amateur radio operator, chances are he's got his own radio. Yeah. So this kind of gives you an idea anyway. It shows you, it depicts the range capabilities of wherever it is that you're at. Now, the other thing, of course, that's going to be a determining factor on how far you're going to go is how high this is, how efficient it is. If this happens to be up on a mountaintop, you bet. A lot better. Okay? Let me see if I can demonstrate that. K7 POF, K7 POF, K0 CKE. Okay, now you heard that little squelch tail at the end there? It's the chunk. Yep. Is there anybody on the 7000 machine that can give me a quick demonstration on a HT from Cornville? '87 AU K0 CKE, back to you. Appreciate that. How far, whereabouts on 17 are you located? Okay, roger on that. Copy exit 227. Appreciate that very much. Thank you a lot. K0 CKE will be clear and standing by. Have a good day. Okay, that's what's known as the Mangus Mountain repeater. It's up there on Mangus Mountain. I would thought possibly we were going to get somebody that would really impress you coming back from Prescott, but this guy's even more impressive. Okay?
He's just north of Phoenix. He's probably not even to Black Canyon City.
Yeah, he's up there by Anthem, somewhere in that area. Okay? So that kind of gives you an idea what we're talking about as far as antenna height goes. Okay? Our antenna isn't very high, is it? I mean, this is it. Okay? His antenna isn't very high. His antenna is probably not any higher than that off the ground since he's in his vehicle, traveling up the road. But that gives you an idea. We don't utilize much of the way of repeater as far as Verde Valley emergency communication association. And the reason that we don't is so that we don't rely upon the repeater. No. The power grid goes to hell in a handbasket. The standby power supply goes to heck, you know, which may be a generator, maybe LP run. It may be just strictly on batteries. How long is it going to last? Yeah, maybe 7 days max. So therefore, that's the very reason why we try to stay away from repeaters. The other problem is, if the repeater just plain cracks up and dies in the middle of winter, you aren't going to find too many people getting up there, okay, through a couple, 3 feet of snow to fix it. Yep.
This one he was just talking.
Yeah.
That's at 8,000 feet.
And they're all the powers in
Repeaters operate on
Different frequencies. That's what we're looking at here. The frequency here for this one is 147,000. Okay. In addition to that, we also have to have PL tone, which is a private line tone, okay, that dictates the fact that we can get into that one. Now, we could have 5 different repeaters, all on 147.000, and we'll have to have 7 different PL tones access to, okay? But they could all be, you know, I mean, there could be one on Mount Eldon, and there could be one on there, and one on Copper Canyon, or wherever the case happens to be. So it's a different PL tone on each one. We can access each one. So we would have to change that tone selector because we'd have to have that PL tone into the radio in order to access it. And the PL tone is what's known as a sub-audible tone. Okay, a lot of them are 100 hertz, 123 hertz, 98.6 hertz, and things like that. So, for the most part, you can hear it if you've got a really good ear, but it's really tough. but it's there. It's there every time you press the key, except for the Simplex. We don't need a PLC. Okay, Simplex is where we're transmitting and receiving on the same frequency.
Bob, you bring the guys back in the shade.
Okay.
Might be.
No, there are no stupid questions. There are none.
Okay. Let's say that
His sunglasses are like
enemy
amplifying
takes that
holes.
repeater and he RDF views on that
No.
because he can't tell where.
That repeater
Is that for
transmits
the
at 360 degrees. All he can do, he can locate where that repeater location is if he's really good. Other than that, he won't know diddly squat. I mean, he could be standing right next to you or within 100 yards of you, and he'd never find you.
Are there privately owned? Are these repeaters self-owned?
For the most part, they're all privately owned. They're usually owned by a repeater club or organization or association.
That makes it available to the public.
Right, and they have to be listed as an open repeater in order for, you and I to use it.
We could, however, set up a privately run repeater that's only open to club members, like the Faraday Foundation. Could be mobile.
Yep, sure.
I've got a VHF repeater in my house that I haven't hooked up to.
If you set up a repeater, do you have to?
Like it doesn't allow air to blow on the bottom
or
of the
somebody
air.
It has to be licensed.
So that way when the shit hits the fan and they want to knock down all the repairs, they know where you're sitting at.
Not unless it's mobile.
Then they don't have
You
a,
are though.
they don't have a clue.
It's harder to register it as a mobile repeater.
I saw two over there by the pole.
Just regular, register as a fixed and put it in the mobile. Put it right in the 2.5.
There you go.
The whole time,
Yeah.
just like taking them off. And
You gotta get that. You gotta get some benches in there, man. You need this set up. I need to get that heater set up for us.
More questions, guys. These are good
That's
questions.
the first thing that comes to my mind when any kind of communications is how can the enemy intercept whatever you're doing. Use it to find you, because in the Coast Guard, that's how we found these boats that
Right.
were literally out there in the middle of nowhere.
Right, channel 16.
Do your count for me.
Yeah.
And that's what they do.
Channel 16, right.
Yeah.
Now, the other thing of it is, as I mentioned before, when, if they're trying to locate your location and they're listening to the repeater, they're obviously not listening to you
They're going to locate the repeater.
Unless
That's where
they-
the signal's coming.
unless they go to the backside.
Yeah.
Okay? To hit a repeater, we need to have two frequencies. Okay? Two frequencies. The repeater is sitting here and it's listening on one frequency. Okay? It's listening. When it transmits, it's transmitting on 800 or 600 megahertz the other way. It could be 600 high or it could be 600 low. All right?
What does that mean, high and low?
Well, all right.
Or below that frequency.
Oh.
Yep. To give you an idea, if we were to go to 146.220 for the VVARA repeater, we would be transmitting on 146.820.
But receiving on
146.220, 600 megahertz offset.
for VHF.
Yep.
5 megahertz. It's 0.6 for VHF and 5 for UHF, right?
No, it's 600.
600 kilohertz for 0.6
Kilohertz, right.
megahertz.
Yep.
The repeater has to receive and transmit at the same time. So it couldn't transmit a signal that is on the same frequency as receiving. It would just blow itself up. I mean, it would just pick it itself up.
Okay, now it's going through some big cans, okay? The cans are known as a duplexer. I didn't really think that we needed to get into something like that today. But that's the idea
We've got
behind it.
technically minded folks here.
Yeah, okay. And technically minded folks want to know.
Absolutely.
Right.
Otherwise they wouldn't ask.
Yes. And the duplexer is that's the key word or the key piece of the element that's necessary in order to be able to receive on one frequency and transmit on another. Okay. Now it doesn't, yeah, for the most part, it does not retransmit the tone. Although you could, when you pick up the person that you're talking to, you can sometimes hear them. It's not really, it's retransmitting it, but it's not. All it's doing is just listening to
Sending out a copy
whatever
of
the
what it
tone,
heard.
right, whatever's on there at that time.
So are you having one guy transmitting and one guy receiving, basically sitting next to each other when you're communicating? Is that how, or are you literally going up and down, transmit, receive?
No. When you're on Simplex, you're both on the same frequency, you're both transmitting, and it's a one-way deal, just like your HDs that you've got there. Okay? One talks and the other one listens.
Yeah. Okay.
All right? And you're both talking and you're both listening on the very same frequency. That's Simplex. When you're operating into a repeater, that's duplex, because you're going through a duplexer. Those big, and they're tall. You know what a milk can looks like? That's kind of the idea. Maybe that's before their time too.
If they've
I
been
saw
to a
one in a
museum, they
museum,
might know
yeah.
what it looks like.
All right.
I think it's generational.
Yeah. Well, that's the kind of idea that you have. Realistically, they're about an 8-inch cylinder, and there's usually about 4 of them that are in there, and they're approximately 3 feet high. Okay. Normally, the majority of the repeaters in this area here all transmit about 40 to 60 watts. That's about their maximum. What gives them the range? Their height, right? That's one. What else gives them the range?
Correct antenna.
Power.
The correct antenna. And the correct wire, absolutely. Because you know what the size of this is. This is roughly 1/2 inch, okay? This is about 1/4 inch, okay? Now, the majority of all of the repeaters that are up on Mangus, hang tight for a second, have what's known as hard line, okay? This stuff could be 1 1/4 inch, 1.5 inches, or up as far as 2 inches if they've got a really long stint to go.
Jack, you're talking about the diameter of the cable.
Yes.
Okay.
Yep. And they use some very expensive connectors.
What type of material is in it? Is it microfiber, copper?
It's all copper.
Okay.
Yep.
So it could be repairable by an average.
Coaxial.
It's pretty tough. I mean, it's not really bendable. Okay. We normally bring it down into the shelter. Okay. We have an end on it. It's normally an end connector, and we don't have an end connector right here to show you, but it's a little different. It's called a UHF end connector. These are PL259s. They are also UHF, but the other one is a little more spendy and more costly than that. Okay, so we have
You're not
a
talking
lot
about the
less
BNC connector.
line loss. It's something like that.
You're talking about the BNC connectors?
No.
And then
not.
for repair, you're basically what you're showing is you would, like any kind of a connector, male, female connector, you could put those on where you need to repair and literally screw it back together, or can
You
can
could,
there
but
be
there's a
break
loss
in
in
the
there
line?
when you do that.
You're losing, you said?
You bet.
The more connectors you add, the more line loss.
Signal loss.
Absolutely.
Yeah, okay.
I have a question. Now
Yep.
I was talking about the frequency, the wavelength, and penetration of walls and
Sure.
terrain.
You bet.
Because of the Wi-Fi, which is it's a radio signal still,
Yep.
lower frequencies penetrate walls better than high frequencies. You said that doesn't quite apply with radio.
Well, Wi-Fi normally runs at about 1200 megahertz, right in there. 800 to 1200 megahertz.
What is the 2.4 gigahertz and 5 gigahertz?
Well, 2.4 is getting up into the microwave range, okay? Where you normally have a parabolic dish and a LNA that's sitting out here that's receiving the signal. This is very directional, okay? And the reason that they mount those outside is so that you've got fewer amount of interference in there. Okay. All right. And you brought up a good point. Let's take Jack's residence, for example. Okay. Let's do that. Jack's residence is basically an adobe stucco fixture on the house. In order to accomplish this capability, they use a wire mesh, okay, before they put this adobe fixture, you know, the structure on the wire mesh. What happens is, it's just like a screen room. A screen room is one that we use in radio technology to eliminate all the other signals that may be taking place throughout the local vicinity, so that we've got, basically, for all practical purposes, a quiet room.
A Faraday.
That's what Jack has over here. Okay?
My house is radio opaque.
It's also a metal building.
It's a metal
It's
building.
stucco on the outside, so it's even more.
Yeah.
His walls got metal inside too. So.
That's what I'm saying. It's a
Yeah.
screen. It's that screen that does it, and it'll block out the majority of all your signals. So that's why it's necessary, with all practical purposes, for Jack to have an antenna of some type up the side of the building there, and eliminating, you know, emanating from, you know, the rooftop preferably. He's going to have a better signal, transmit and receive.
This whole house is like a Faraday cage.
Yeah.
Yeah, I have a naturally built Faraday cage for a home.
Yeah.
There's an EMP.
Except for anything coming through the windows, and then I got metal boxes. Everything is stored in metal boxes like this.
would fit out.
Well, we've been hit by several over the past couple, 3 months, and it all depends upon the power, you know, of what we're hitting with. You know, because, you know, for all practical purposes, the majority of the time, your radio is already in a metal box. Okay, it's got a case, cover, you know, sides, and so on like that. All you really need to do is to disconnect the antenna. Now, you can do that a couple ways. Unscrew it, or put a connector on there, a switch. You got your antenna disconnected during any of that time. Lightning storms are a good time to disconnect. Any possible knowledge of any EMTs in there, you could disconnect again, and you're good to go.
You're touching on my class.
I'm sorry. just a little nudge on the side.
Okay, nice segue.
Yeah.
Okay, any other questions, guys? Time check.
13:05.
Perfect timing. All right. 10-minute break. Guys, bring my Xantrex power pack and the charger back down here in 10 minutes.
That
Thing
big
on
box we
wheels.
rolled up there.
The thing we rolled up there, that's my Xantrex power pack. Please bring back down here as part of my class.
I'll gladly go get it for you.
All right.
Fuck it. No problem.
10-minute break, guys. Back in a quarter after. Yeah, Bob, before you start, would you operate my still camera so I can get some still photos for the website? Okay, there's a long pause between each shot. Yeah, so you just press there when you're ready to shoot.
Good.
Your zoom is on the right there where your right thumb is.
Yes, it is.
Okay. Gentlemen, my name is Jack Foote. I will be your instructor for the next block of instruction. Everybody on your feet. Shake it off. Turn around. And have a seat again. Now, I always do this at the beginning of each class so that people have their blood pumping. They at least pay attention for the first 30 seconds. Okay, today's class is on two primary concepts. One is on the concept of the Faraday cage. The other one is on the concept of minimal radio equipment for maximum performance. Faraday cage was invented, not surprisingly, by a man named Faraday. Concept is all metal enclosure will redirect magnetic energy, such as a geomagnetic storm or electromagnetic pulse, around the outside of the box. You can build such a cage with literally cage material, or you can use a solid steel box to do it. The key point to make is it has to be fully enclosed. A fully enclosed cookie tin is a Faraday cage if you put something electronic inside of it, and if it is properly grounded. When I store this box, I store it on the ground. I'm eventually going to have cables attached to all of my Faraday cage boxes so that they actually attach to the ground portion of the electrical plugs in my house. That will mean that they are properly grounded. Electromagnetic energy passes around the box and does not have the opportunity to affect the circuitry within the box. If it does affect the circuitry within the box, the electromagnetic pulse will generate high voltages. Basic concept of the electric generator. If you have electricity passing through a wire, if you have magnetism passing through a wire, that wire will generate electromagnetic charge. That can destroy your delicate electronics. To a certain degree, your metal case radios are protected, but if you have an antenna attached, you're not, because that's going to come straight through the antenna into the box. So, that said, you can build a Faraday cage with any standard ammo can from the military. You may have seen the larger boxes that I have, 4 feet long, and about as big around as these are. That's where I store most of my radios, inside other cans like this one. I'll show you when we get back inside, but I have a 20 millimeter can. It's about twice this size that I keep inside the larger can. So I'm not taking chances with EMP on the majority of my radio equipment. It's there for when things go bad and we have to start setting these things up in order to be able to communicate with each other over distances. All right, part 2. Contained in this 150 caliber ammo can is additional shielding. The shielding is in place because I don't take half measures whenever I have a chance to do it better. So, next thing we're going to cover is the Yaesu FT817 radio. This is a multi-band radio in a very small package. I can fit this radio into my miniature backpack, no bigger than the carrier that he has on his back right now. With it I can carry extra batteries, I can carry everything that's in this ammo can with the exception of the amplifier. Now, these radios have a maximum output of 5 watts, not much more than a handheld. The tuning and the technology is much greater than inside of a handheld. And because I can tune this to just about every, actually every amateur band that is available to us in the United States, it has a wide range of capability. With the right antenna, I can talk to just about anywhere in the world if the conditions are right. This does not take the place of the large base station unit, but it does give you an expanded capability when you are on foot that you would not have otherwise. If you add an amplifier to your backpack and extra batteries to power it, you can put out a lot of wattage. This one is rated at 60 watts. So I can take an output of 5 watts, amp it up to 60. Contained in here also the AC adapters for charging the radio and for charging the external batteries. The external batteries are nothing more than the old style VC or VHS camera batteries. These are available just about anywhere. But with these and the right adapter, I can carry those inside of my backpack along with the internal batteries that are contained in here, and I can run for a pretty good long period of time. I've gone as long as 6 hours with one battery change. Okay, now that said, let us discuss the additional features and options. This is not native to the ASU. This is an add-on that I put in my own kit. This is a flexible external antenna. It's a BNC connector. And I should pause long enough to say that the FT817 is so versatile that it includes both the SO239 PL259 type connector that Bob was talking about and the BNC type connector that you find on many handhelds. I can switch between these two antenna leads depending on which one I want to use. So, if I want to set up a quick external antenna, I need to do nothing more than find a handy branch. I have set up my external antenna. It's not perfect performance, but it's a lot better performance than the little rubber duckies that come with the radio out of the package. Like I said, this is set up to give you a lot of versatility right out of the package. All I can do is add to that versatility by adding other capabilities, other accessories. So, in a backpack configuration, this is how I'm going to be set up. This is going to be sticking out of a pocket in the back of my backpack. I'll be running either off of the internal rechargeable batteries or off of the external rechargeable batteries. Or I can run it directly off of 110 volt AC, or I can run it off 12 volt, say the cigarette lighter in my car, or the 12 volt adapter that you see on the Xantrex power pack on my right. With the Xantrex, I can operate without a recharge for days, because this thing draws so little power. Not that I can haul that around everywhere I go, but if I'm in a fixed location, if I have a vehicle, even if I have a dog sled, I can move this around from place to place and operate for up to a week off of the charge in those batteries that are contained inside the Xantrex. Because when I'm operating off of the Xantrex using 12 volt directly rather than converting it to 110 volt, which it does have the capability of doing, then I'm using it in the most efficient mode. It'll last longer than it would at 110 because I'm not burning power to run the 110 converter. Types of microphones. The standard microphone is one you're probably all familiar with, just like you see on CV radios. However, this one has controls on the top that allow me to choose different bands and to operate other features of the radio.
Is that
Custom-
a speaker mic, Jack?
Sorry?
Is that a speaker mic?
No. When I'm using this microphone, I am using the built-in speaker on the radio itself. So I have to have it where I can hear it, like in a backpack, or mount it to where I can see it. But I can't bury it in my backpacks, otherwise it won't work. Now sometimes you don't want to be heard by the speaker that is quite loud. Turn it all the way up. So I had a good friend of mine who's very familiar with the FT817 series of radios build me an adapted version of the military handset, the H150, I believe, or H140. This is the same handset that you see on military radios from the Vietnam era forward. I put the plastic bag on that because I know these things, the seals break down sometimes, even on the new ones. It'll leak in the rain, so as an added precaution, I keep mine in the sleeve. But the basic radio telephone handset, and an adapter to make it possible to use with the FT817. So, the other things that I have added are your antenna adapters to give me right angles if I need to set it down and run it in the mode that you see it right here, where it's just sitting on a flat surface. Because otherwise, I got to stand it up like this, and it's kind of wobbly. I'd rather lay it down and use the adapters like we're going to be using today. So, lastly, in addition to the manual controls on the front of the Yaesu FT817, there is an adapter to allow you to control it from software on your laptop, which is really frackin' cool. When you can control what your radio is doing and even initiate transmissions on the radio using your computer controls. Maybe we'll have the opportunity to set that up in the commo van someday, Mark. I would love to be able to do that, where we can do scans based on the controls on a laptop. So it's not very, very powerful, but it is very, very versatile and offers a lot of bang for the buck. Typical cost of one of these is around $600. And like I said, the external batteries are not made by Yaesu, but are available online. Fairly cheap nowadays. These are not that bad. The guy who makes the adapter that allows you to connect it directly to the outside of the radio, he isn't making a whole lot of money off of that. Questions? Time check.
13:27.
Man, I did that fast. That was 12 minutes of burning through it. Because I wanted to get done in a hurry. Now, why do you suppose I wanted to get done in a hurry?
You got something else you want to do more?
Because we have a surprise for you. Bob, would you like to describe the surprise?
Well, I've already alluded to it.
Alluded to it, but not explained it.
No.
Strippers, if you can find them. Oh, right there. Press and hold.
Strippers, look at the tool.
Yeah.
Nah. Thanks for taking the pictures.
We just on a hike.
Okay. We're going to use this radio at 2 o'clock to contact the network that Bob and I are a part of, the Verde Valley Amateur Emergency Communications, or just Emergency?
Emergency Radio Communication. Emergency Communications Association.
There you go. Did y'all file for a nonprofit yet?
We are an LLP.
Yeah. All right, so Bob, I'll leave this in place and I'll get everything set up while you guys do what you're going to do.
I got one more item I got to get out of my truck.
All right, everybody take a 5-minute break.
Yep.
I think the more of these you kill, the more you kill off.
Now you're killing their buddies.
I got a little bit of liquid, but I think it was my saliva. Oh.
It's not a camelback anymore, it's a douchebag.
I need to turn off the tone setting for the repeater.
Well, you can leave. It does. You know, with that jack, it doesn't make any difference whether you got tone on it or not.
Oh, okay. All right, so power it back off. Appear to be leaking Gatorade. That's from the hat. It's sweat and dirt. So, rear antenna.
You have a problem, bro?
Power up. 146.400, correct?
Yep.
AA70V?
Yep.
AA70V, this is KE7FDZ, over.
I don't hear you, Jack.
So where did I go wrong?
Probably not very. It's been out sitting out there all day.
Super heated.
Need to eat some soup.
Oh, for some reason it set itself back to the front antenna.
Chilly in there.
Okay.
Cool thing about doing that is you don't need
touch memory. Put it in the channel if you can.
Yeah.
120 degrees. Needs to be 160 to kill bacteria and be edible. Run up the drip.
Keep setting itself back to front antenna.
I'd like to know the exact amount, temperature and amount you take.
It's not really that high.
Nothing.
I don't hear you.
It's got to be over 100.
Oh yeah.
Cooler room temperature right now.
That's 100.
It's got to be somewhere 120, 130.
It's still set to rear antenna.
Burning.
Still set to 146.400.
Pull something straight out of my plate. It's 160.
Ah, I see what's wrong.
To make it funny.
Still set. It was still set to offset.
Why are there so many flies over here? You smell that bad?
This is why we practice.
I do.
KE7OV, this is KE7FDZ. Over.
What's really cool about radio waves is
AA7OV, this is KE7FDZ. Over.
You might not be home yet.
Try KK5ML.
KK5ML, this is KE7FDZ. Over.
Oh my God. Nobody's listening. I know we're transmitting.
Yeah, I do too.
We must be reaching out a good long while.
It's siesta.
Siesta time.
We have to be reaching a good long way.
Try KF7IAJ.
KF7IAJ, this is KE7FDZ, transmitting from Camp Sizzle. Over.
We all went and took a break, huh?
Well, still might be on his way home, or whatever. Although we should still be able to pick him up in a mobile if he's on the road. And Aisha should be
Come
around.
back at me, see if I'm even set to receive.
Well, he set to receive.
Well, I can monitor here.
Feed here
Yeah,
too.
but if you transmit, can I receive you?
You bet. KF7FDZ K0CKE.
K0CK, this is KE7FDZ. Over.
Roger, you're 5x5.
Roger, KE7FDZ clear.